In this lecture, we take the example based on the polar curve of orthogonal trajectory. So the question is, find the orthogonal trajectory of the curve r square, which is equal to a square cos 2 theta. So this is the curve like this, right? That this is geometrical representation of this curve r square equal to a square cos 2 theta. So now we have to find the orthogonal trajectory of the curve r square is equal to a square cos 2 theta. Let us give it equation number 1. Now, this is the polar curve. So in case of polar curve, we know that it is nothing but the relation between r and theta. Here, this a is the arbitrary constant. So now, if you want to find out the orthogonal trajectory of the given curve, we have to first find the differential equation of r square equal to a square cos 2 theta. So how to find differential equation of this curve? So we have to just differentiate, since there is one arbitrary constant a. So we have to differentiate this equation one time, and then using the equation number 1 and the derivative form, we have to eliminate the arbitrary constant a. Then we get the differential equation of the given curve. So differentiating equation 1 with respect to theta, we have derivative of r square is 2r, again derivative of r is dr d theta, which is equal to uh, a square is constant, so we can take a square common outside. Derivative of cos 2 theta is minus sine 2 theta, and again derivative of 2 theta is 2. So I think this is clear. Derivative of r square is 2r, again derivative of r is dr d theta, and which is equal to, we have taken a square outside, derivative of cos 2 theta is minus sine 2 theta, and again derivative of 2 theta is 2. So now here 2 and 2, this 2 will be cancelled, and now we have r times of dr d theta, which is equal to, now since this is the equation number 1, we can say that this is equation number 2, we can say that. So from equation number 1 and equation number 2, we have to eliminate this arbitrary constant a square. So from equation number 1, what is the value of a square? It is nothing but r square upon cos 2 theta. What is the value of a square? It is r square upon cos 2 theta. So now we have to put the value of a square is r square upon cos 2 theta. Now since this r and this r, one r will cancel. So we have dr d theta, which is equal to minus r, and this is sine 2 theta upon cos 2 theta is nothing but tan 2 theta. So let us give it equation number 2. So this is nothing but the differential equation of the given family of curve. This is the differential equation of the given family of curve. Now if you want to find out its orthogonal trajectory, then this dr d theta, this dr d theta should be replaced by minus r square d theta dr. So this dr d theta is replaced by minus r square d theta dr. So now let us replace it. What will happen? Dr d theta, which is equal to minus r square d theta dr, and the right hand side is minus r tan 2 theta. This minus minus will cancel. One r should also cancel. So we have r d theta dr, r d theta dr, which is equal to tan 2 theta. Or we can write down d theta by this tan 2 theta and dr upon r. Now this is, or we can also write down dr upon r, which is equal to 1 upon tan 2 theta is nothing but cot 2 theta. Let us consider this as 3. So this is differential equation of orthogonal trajectory of the given curve. And now if we solve this differential equation, if we get the general solution of this differential equation, then we will get the equation of orthogonal trajectory of the given curve. So since the equation number 3 is variable separable form, so separating variables and integrating, we have integration of 1 upon x is equal to log x. So integration of 1 upon r with respect to r is log of r. And what is the integration of cot 2 theta? Integration of cot 2 theta is equal to log of sine 2 theta. And since 2 theta is multiplied by 2, this is 2. So it will be divided by 2 plus integrating constant c. So it can be written as 2 log r, which is equal to log sine 2 theta plus 2c. Now this 2 goes to this side and it will become log r square. Log r square is equal to sine 2 theta. And let us consider this 2c is nothing but log a square. So this is log sine 2 theta plus log a square. So log a plus b is nothing but log a b. So this can be written as log of r square, which is equal to log of a square sine 2 theta. And if we take anti-log on both the sides, we have r square is equal to a square sine 2 theta. This is the desired equation of orthogonal trajectories of the given curve. Now, this is the curve r square, which is equal to a square sine 2 theta, and this is nothing but the orthogonal trajectory of the given curve r square equal to a square cos 2 theta. Thank you.